Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mask coder this side once again. Okay, so the question we are going to deal this are is generate parenthesis. It is lead code question number 12, 22. So what does the question says? Question says that you have been provided with the value n, right? In the case given below, it is n equals to 3. Now you have to generate all the pair of parentheses, right? All the three pairs of parentheses, right? So I have to arrange 1, 2, 3 these pair of parentheses into an expression such that the parenthesis set is valid. So you can see the first example, like one of the example is I can place this like this, right? This is a valid parenthesis, right? Now I can also place this something like this, right? This is also a valid parenthesis. Another one is this is also a valid parenthesis, right? But what is an invalid parenthesis? That is important to understand, right? So somewhere if this closing bracket is present but its corresponding opening present is not present on the left of it, in that case it is an parenthesis, right? You can see there are three closing brackets, three open brackets, but it is not a valid expression, right? So you can see for n equals to 3, 1, 2, 3, 4, 5 are such parentheses that can be generated, right? I hope you are clear with the question, right? You have to provide me all the possible three pairs of parentheses, right? Or n pairs of parentheses. So my requirement is from you, provide all possible combinations, right? All possible combinations. Now whenever you require all possible combinations, the first thing that should come to your mind is, can I use recursion here? And the answer to this is yes, you have to use recursion here only, right? So after figuring out that this question will be solved by recursion, the problem actually becomes very simple. How? So for n pairs, what is the length of the combination? For n pairs, that is for 3 pairs, I will have to attach 3 opening brackets with 3 closing brackets. That is 1, 2, 3, 4, 5, 6. That is 2 into n. My length of the combination will be, just figure of things I have to figure out. Length of combination will be 2n. Length of combination will be 2n. N opening brackets and closing brackets, right? So what will I do? I will make an empty string, right? And I will start putting it characters. At any operation, I can actually put a opening bracket or a closing bracket, right? At any operation, I can either put this or this. And whenever my length of my current string becomes equals to 2n, in that case, I will check my string. I will check my string, right? And if that is a valid string, now how will I check if that is a valid string? So that is a whole lot problem. I've already discussed it on my channel. I would like you to watch for it, because that problem is known as valid parenthesis, right? That is also discussed in the LeetCode medium section only. So you please just go and watch it out, okay? So if that is a valid parenthesis, in that case push it into your answer, otherwise just move forward with the another cases. So we figure out it was recursion, we figure out the flow. How will I solve it? I will say that suppose my function is solve, it is taking my index where I have to provide the value, right? And it is taking my n. So let us suppose the string here is an current, right? The string name is current. So if current dot length equals to 2n, in that case what will I do? I will say if valid, if cur is a valid, if this function returns true, I will say push back, push it into your answer, right? And then return. Otherwise if it is not valid, also that, then also you will return, because you have actually formed the string. You will not form a longer string, right? Otherwise if this is not the case, then you have to add some letters. So the case can be either, you can actually solve for the next index, n will remain same, now current will be adding opening bracket, right? Or in the other case you will be adding, current will be adding smaller case, this will be index plus 1, this will be index plus 1. You can actually rule out the index. I actually use index to avoid current dot length, okay? I can actually use index to equate it with 2 into n, right? And then simply return, right? This will be your answer. How will the code work? Right? How will the code work? For this pseudocode, how will the code work? Suppose for n equals to 2, right? N equals to 2. We are starting with the empty string right now. So empty string, I will move to these two steps. So recursion will be called for two functions, right? Two children. I will attach a simple opening bracket or a closing bracket. Exploring this one, I can attach a closing opening bracket again or a closing bracket. Seeing this one, see like opening and then closing, opening and opening and closing. Now exploring this, opening, or I will attach a closing to the end. Now whenever I encounter a length of 4, that is equals to 2 into 2, that is 2n, right? Now this length is actually finished. I have got a string. I have to check if it is valid or not. Now this is definitely not valid. We have discussed that how will the valid parenthesis code will work. I will surely encourage you to check it out. Please go and check it out. The link is in the description. So you can see that this is not valid. So what will I say? I will say return without pushing. Now this is also not valid. Return without pushing. The current call for this is finished. Return. Now here I can attach a closing opening bracket here, or I can attach a closing bracket, right? If I attach a opening bracket, this is definitely not a valid parenthesis, but this is a valid parenthesis. So what will I say? I have my first answer value, that is opening, closing. This is my first one. Now moving forward, this will also return and this will also return. Okay, moving to this one. Now it can give rise to 1 2 1 or 1 2 2. This can give rise to 1 2 1 1 or 1 2 1 2, and this can give rise to two more, that is opening, closing, opening, or opening, closing. Now you can see that this is not a valid substring, so it will return without pushing, but this is a valid substring. So another answer is opening, closing. Return it again. Now talking about this, is it valid? No, it is not valid. Is it valid? No, it is not valid. So both the returns, and this will also return, this will also return, this will also return. Talking about this one, the recursion subtree for this one, let me draw it down here. Recursion subtree for the simple closing bracket. Now attach an opening to it. That is, it can become like this, or it can become like this. It can become like this, or it can become like this. First of all, I can draw the whole recursion subtree. You know, it will look something or something more or less like this only. But will any substring arising from this be a valid substring? No, because I encountered a closing subparenthesis on the first index. That is possible, right? I need to encounter a closing parenthesis, opening parenthesis before a closing parenthesis, right? So this will not give me any answer, and I can actually say that for n equals to 2, I have only two valid combinations that are listed here, and it will return me to this, right? Now the main focus area where I wanted to draw your attention is this one. Why did I cancel out this? Right? Like now my motivation is to remove need for valid parenthesis function. What do I mean by valid parenthesis? I don't need to, I want to remove the need for checking the string after getting the string, right? I want to remove that need. So what can I do? Can I say, if I am I have to fill 4 indexes, right? So I can say that I can only place, my condition is I can only place a closing parenthesis if there is a opening parenthesis before it, right? So what can I say? If there is an opening parenthesis, only then and then I can place this, right? Now can I place this again? You will say that opening parenthesis is there, but I will say no. One, like there are two closing parentheses, so I at least need two. Only then I can place. So what can I say before it? I can say, and the number of closing parentheses should be less than number of opening parentheses, right? This is my condition. So how will my code work for it? So I will say I will get a solve function. I will take my index into account. I will take my current substring. I will take my n. Now I will include a new parameter, that is count. What is count? Count is the number of opening parentheses. Where it is number of opening parentheses in cur, right? Now what will I say? If my index equals to 2n, That means I have made my current string contains all the values I wanted, right? Now if this index equals to 2n, what is the condition that cur is a valid substring? For that, it will be if count equals to 0. Only then all the string is balanced, right? In that case, push it into the answer. Push cur to answer, right? Otherwise, if it is not so, return, right? Okay. Moving forward, what is the recursion case? So if my count is equals to 0, if my count is equals to 0, that is there is no opening parenthesis that needs to be balanced out. In that case, I can only go with current subs. I can only go with placing a opening parenthesis. So I will say solve for next index, that is index plus 1. My current will become cur plus opening parenthesis. It will remain n, and count will increase. Count will increase to 1, right? Now if count equal to 0, done. Now if count is not equal to 0, that is I can either place this or I can either place this, right? This will increase the count, this will decrease the count, because it will be taking away one available opening parenthesis. So I will say solve for index plus 1 with current plus opening parenthesis and count plus 1, right? And similarly solve for index plus 1, current plus closing parenthesis and count minus 1, right? And now simply return. This will actually give me the correct recursion. I hope you are getting my point, what I am trying to say. How will the subtree work? So my subtree will work with an empty string and a 0 value, right? Okay, now what will I say? If because it is 0, so I can actually push only this one, no other sub case. Now because it is 1, I can actually get 2, that is this one or this one. Now this one will come with a 0 and this one will come with a 1. Not 2, not 1, it is 2 actually. Now this one is 0, so I can actually put only one case, that is opening bracket with a 1 count. And now this is not a recursion subcase here. CC2, I can actually place CC and closing, or CC and again a C. Now with the this one I will decrement it, it will become 1. I will increment it, it will become 3. Talking about this one, C like this pair. Now it is because 1, I can actually make 2 cases out of it. What are 2 cases? So opening, closing, opening, closing. Because it is closing, so 0. Or I can make opening, closing, opening, opening with a 2. Now because the length is 4, I will see it is 0, I will push it into the answer. So my answer will become this one. Because it is length equals to 4, I will say I have had 2. Because it is 2, that means that they are not balanced. So I will just say return. This recursion call done. Talking about this recursion call, because it is 1, I can actually place a closing bracket right now also. So it will become opening, opening, closing, closing with a count of 0, or it can become opening, opening, closing, opening with a count of 2. Again, length equals to 4, 0, push it into the answer. So answer becomes opening, opening, closing, closing. Now return it. Talking about this one, opening, opening, closing, opening, 2. This 2 will not let me push it into the answer, so return it. Return it. Talking about this one, because it is 3, I can actually place any 2. So C, 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 closing, or opening, 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 opening. Because I am putting a closing, so it will decrement 2. Because I am putting a opening, so it will become 4. Both the cases 2 and 4 will not allow to push me to answer. Return, right? And then this will return, and then this will return, this will return, and I can simply return, right? And this will return. Okay, so my answer comes out to be these two. These two are actually same which I encountered in the first approach. Okay, so we will code on both the approaches now. I hope you were able to understand the count functionality and the first case of exploring all the cases, right? Let us try to code it down now. All right, so here we are. I've copy pasted the code from the valid parenthesis from the previous problem only. Now I'm trying to do the coding for the first approach. Coding for the first approach, right? Now, how will this approach work? So I will first create my vector of int answer, right? I will make my string cur as an empty string right now, and I will say solve for, let us say solve 1, because I'm mentioning it as first approach. Solve for index equals to 0, and I will send as it is, cur I will send as it is, an answer, right? What will I say? I will define a function of solve. So void solve 1, it is taking my index, it is taking my n, it is taking my string cur, which is not passed by reference, and it is taking my vector of string answer, which we'll have to push our strings into. My base case is that if index equals to 2 star n, that is the length is complete. So now if my check function returns true for cur, I will push it into the answer. So answer dot push back cur. Otherwise, simply return. Right now for the solve function, solve one for this is for exploring all the cases. So go for an index plus 1 with n and push cur with an open bracket and go for the answer. Otherwise, the other case is solve for index plus 1 with n, push a closing bracket into the answer, into the current string and answer. Right? This is not a dot, this is a comma here. And now after that you can simply return to mark the ending of the function. So this code should run fine. I will simply return, so return your answer. Right? Let us try to compile and run it, hope it will work. And then we will check out for, oh, there has been some error here. So vector of string answer. I have declared it as vector of int, it will be vector of string. Let us try it now. So these are simple type mistakes. I hope you understand it. Okay, so it is working for the sample test cases. Let's try it for submit also. And hold on, because we will be coding the second approach as well. So it is taking a lot of time. Yeah, it has been accepted, right? Okay, let us move on to the next approach. That was approach number 2. So I will comment down the code of solve one only, right? Now let me code it down for the second approach. So my answer and current will remain same. What will I say? I will solve 2 because this is second approach. I will send my index here, my n here, my current here, my answer here, and one more thing, that is count. Count will be initially 0. So let me call for the function solve 2. Void solve 2, which is taking my index, taking my n, string current, and vector of string, and answer, right? And I will take my count. Now if index equals to 2 star n, I will push it only if count is equals to 0. In that case, answer dot push back your current, right? Now otherwise you can simply return and now go for it. So if my count is equals to 0, then I can go for if my count is equals to 0, I can go for solve 2 with index plus 1 and cur. Now because it is 1, so I will just go for the opening bracket with answer and counter plus 1, right? Otherwise, if my count is not equals to 0, I can go for both the cases. That is solve. I will just get it, copy paste it, right? Because that will be a lot easier than typing the whole of it. Control C, Control V, Control V. In the first case, I will add an opening bracket. That will remain same. Otherwise, go for the closing bracket, right? And I will add it in the else clause. Else, and here, and I will simply say return. Let us try to compile and run it now. Hope it will work fine. Oh, it will not work fine. Why? Because I have not mentioned minus. Okay, mention the minus now. Let us try it now. Okay, so it should work fine now. It is running fine. Let us try it for submit as well. So you can see it has been accepted. So thank you for watching. Hope you liked the video. Hope you were able to understand the question, right? So we will continue. We will meet in the next video. Till then, please stay coding and stay safe. Hello. Bye bye.